Hello everybody, today I'm going to show you why the square root of 2 is irrational. Of course, we already know that the square root of 2, right here, is irrational, but why is it irrational? Well, first, let's go back down to the very basics. What does it mean for a number to be irrational? So first, let's define this before going on to square root 2. So a number is irrational if it can be written as the ratio of two numbers, p over q. And it doesn't have to be p over q, but let's just say we have two variables, p over q. And p is an integer, and q is an integer too. And they are coprime, which means that they don't have any least common, they don't have any factors in common except one. So, p over q, they're relatively prime. That's another way to say it. And they're both integers. So, what we're going to do is, we're going to prove that the square root of 2 cannot be written as the ratio of p over q, where, blah, blah, blah. So, first what we're going to do is we're going to write the square root of 2 as p over q, which we don't want to happen. So you may be wondering, why are we doing this? Sorry, that's kind of bad, but why are we writing this as p over q? And what we're doing is we're actually doing something called proof by contradiction. Proof by contradiction is basically saying the thing that you don't want to prove. So what we're doing is we're assuming that the square root of 2 is rational. And after you assume that that thing is actually true, the thing that you're not trying to prove is actually true, then you just keep going and you see if that actually, then you go and you see if you find any contradictions. And by this, then you'll see if that number, and by doing this, we can see if the square root of 2 is irrational. And right now, that was kind of confusing. I explained it really badly. So what we're going to do is we're just going to keep going. So we're just going to do what we normally do, like when we're solving for a variable. So we're first going to square because we want to get rid of the the square root. So we get 2 equals p squared over q squared. And then we multiply by q squared, and we get that 2q squared equals p squared. Okay, so what we can deduce from here is that p squared is even because 2 times q squared equals p squared, which means that p must be even since it's a multiple of 2. P squared must be even. And since p squared is even, therefore p must also be even, because if p was odd, then p squared would be odd. So p has to be even. It's the only way that p squared will be even. So from here, we can write p as 2r, 2 times r, which is some integer r. And this means that 2q squared now equals 4r squared. So somehow this guy equals 4r squared, where r is an integer. Then we divide by 2, and we get that q squared equals 2r squared. And from here, we can obviously see that q is also even. It's the same case as above, where we got 2q squared equals p squared. It's the same. Q squared is also even. So, now that we're done with this, that means p and q are both even, which means that we have a contradiction, because guess what? P and q have to be relatively prime, and since they both share a common factor, that means that we have a contradiction, and therefore the square root of 2 is irrational, which means that we have a contradiction, and what we assumed is wrong. So thanks for watching. I hope you enjoyed, And make sure to check out my other videos because I have more videos that are also interesting. And if you enjoyed this video, again, like and subscribe. Thanks for watching.